All right, so guys, I was seeing in the messages, one of the questions is how do we find that critical value when we're going to do our hypothesis testing? So I'm going to kind of just make this up, okay? So suppose I'm going to say, suppose my alpha is 0.10. Now, not only do I need to know what my alpha, and we're going to assume that we know our population standard deviation. So we have our value of sigma, whatever it happens to be. I'm just going to make this up, 4.8. It's not really important right now. And the way when we're finding our critical value, the one thing that we have to look at is we have to look at our ha, right? And our ha usually says something like, I'm going to make this up. Suppose mu is greater than, again, it's not really important, but I'm going to say 38, okay? Something like this. So when I'm looking at my ha, this is going to be a right-tailed test, okay? So let me explain what that means. That means that I'm going to draw my standard normal curve, something like this, right? And because this is a right-tailed test, what I'm going to do is I'm going to find my critical value right here. And this is telling me that the area to the right of my curve is 0.10. So what I'm trying to do is I'm trying to see, can I find this value right here? So the way I'm going to do this, y'all, I'm going to use my inverse norm. But the one thing I'm going to mention is whether I use my inverse norm, so let me just write this down here, my inverse norm, or if I use my table, either one, those things always tell me the area to the left, okay? So since this happens to be a right-tailed test, and I know that the area to the right is 0.10, what that's really telling me is that this area here, y'all, is 0.90, right? So that means that when I'm going to go inverse norm, I'm going to go inverse norm of 0.90, okay? And so let me do this on my calculator, so let me clear all this business out. So I'm going to go second in vars. I'm going to go to inverse norm of 0.90, okay? And if you notice the number I'm coming up with like 1.28, right? Okay, so then let me come back over here. We know that this number is now a 1.28. Okay, now that we have that, then the next thing we're going to do is we're going to say, look, this here is my rejection region, and this region here is my fail to reject region, okay? So then when we find our standardized test statistic, wherever that value is going to be, let me come back to the black part here. Okay, I thought I was in black. Here we go. Okay, so now whenever I find my standardized test statistic, I need to figure out, is it going to fall to the left of 1.28, which would be in my fail to reject region, or is it going to fall to the right of 1.28, which would be my rejection region, okay? So I want you to notice something. I didn't use this number here, but I had to have that in order for me to use the inverse norm. Okay, so we just did this for a right-tailed test. Now, we're going to come back, we're going to do the same type of problem. So look, we're going to say our alpha is 0.10. We're going to say our standard deviation, what did I use before? I didn't really need to know the number, 4.8. Okay, now suppose we say our HA, that mu is smaller than, I'll use the same number I had before, 38. Okay, so again, the alternate tells me whether this is a left tail, right tail, or two-tail test. So when I look at this, this is telling me, hey, you know what? This is a left-tailed test, okay? And so what I'm going to do now is I'm going to draw my standard normal curve again, right? And I'm going to do this, okay. And since my alpha right here is 0.10, I'm going to come back over here, and we're going to say the area to the left, right here, y'all, is 0.10, and we want to find our critical value, right? So again, whether I use my table or whether I go with my inverse norm or the table, remember, they both tell me the area to the left, right? So look what we're going to do. We're going to come back. We're going to take our calculator. Let's clear all this business. We're going to go second vars. We're going to go to our inverse norm, and we're going to go 0.10, I'm sorry. And look at the number I'm coming up with now, a negative 1.28, right? So this number right here is a negative 1.28. So remember what this is telling me? This here, y'all, right here, this is my rejection region, and this is my fail to reject region, right? So again, now when we do our standardized test statistic, right, we're going to figure out, are we going to fall to the left of negative 1.28, which would mean we're going to reject our null hypothesis, or we're going to fall to the right of negative 1.28, which would mean we're going to fall in the fail to reject region, right? Okay, so I'm going to do another part right here. Same kind of thing, y'all. I'm still kind of working with the same information that we had. So let me say, we're saying, okay, alpha is 0.10. So let's go, alpha is 0.10. And again, if you notice, I'm not really using these other values right now, but it's important that I know some of these things. Okay, so now we're going to say, what about my alternate hypothesis? Or my alternate hypothesis. So we've done right tail, we've done left tail. This is how we know if it's two-tailed. If it's not equal to, what number was I using? 38, okay? So if it's not equal to 38, this is what we're going to do. I'm going to come back over here. We're going to draw the same picture that we had before. But now this here, y'all, is a two-tailed test. Oops. Okay, and then the way I find these values here, these values are alpha divided by 2. Alpha divided by 2. So remember, if my alpha was 0.10, half of 0.10, that's telling me the area to the left there is 0.5, and the area to the right over here is 0.5. I'm going to do the same thing we did before. We're going to go inverse norm, but now we're going to use 0.5. So let's do that again. Second bars, inverse norm, 0.05, and negative 1.64. Okay, so I'll click over here, and this value here is negative 1.64. So, oops. So this one here, y'all, happens to be a positive 1.64. Okay, again, what is this telling me? That these here are my rejection regions, and this is my fail to reject region. So again, when we do this part, right, and we're trying to figure out our standardized test statistic, we're going to see, okay, are we going to fall somewhere in the fail to reject region, say right in here? Or are we going to fall in the rejection region, which would be to the left of negative 1.64 and the right of 1.64, okay? So I wanted to explain that just to make sure that we're good with this kind of stuff. Y'all, I'm going to do the same thing here. So I'm going to do another slide, okay? And I'll do the same thing. Look, I'm going to say alpha is 0.10. But now I don't know sigma. I know my sample standard deviation. I'm going to use the same number, 4.8. Now, the other thing I need to know here, y'all, I need to know my value of n, okay? So remember what n is. N is just in a random sample of so many. Okay, so I'm going to say, I'm just going to make this up. Suppose n happens to be, I don't know, say 35. Okay, we'll do the same thing. Look, let's go through and say that our ha is saying that mu is greater than, I'm still using the same numbers, 38, okay? Now, remember what this is telling me. This is telling me that now I have a right-tailed test, okay? So look, I'm going to come back over here. I'm going to draw my curve, right? Here's my alpha. We're a right-tailed test. This value here is 0.10. Now, the only part that's really different is because we don't have our sigma. We have our sample standard deviation. We're going to use what we call the inverse t, okay? The inverse t, we're going to have two numbers. The first one is going to be the area, again, still to the left, y'all. And the second number, the second number right here is going to be our degrees freedom, okay? So look, let's go through the same thing here again. Remember, my area to the left over here, this is still 0.90, right? Because the whole thing has to add up to 1. So that's 0.90. Remember how we find our degrees freedom? We look at our value of n, and we say this is just going to be 1 less. So this is going to be, oops, a 34, okay? So look, let me show you how I'm going to do this part on my calculator again. So I'm going to come here. We're going to clear all this. We're going to go second vars. We're going to go to inverse t. We're going to put 0.90, comma. We said our degrees freedom was 34. And so the value that I'm coming up with here, 1.31. Okay. So right here, y'all, this value is a 1.31. What does that mean? Same thing like we did before. That's my reject region. This is my fail to reject, region, okay? So then again, we're gonna say when we find our standardized test statistic, are we gonna fall to the left of 1.31, which means we reject, or are we gonna fall to the right of 1.31? Sorry, the left is fail to reject and the right's gonna be reject, okay? So look, I'm going to do the other two just so again, so that we have an idea of how to do this. So look, I'm going to use the same values that I'm using before. So look, we're going to say alpha is 0.10, right? Oops. And my S is 4.8. My N is 35, okay? And so we did a right tail test, so now let's do a left tail test. So we're going to say HA says that mu is smaller than 38, okay? This is telling me this is a left-tailed test, okay? My picture is going to look very similar, right? So I'm going to do this number here, okay? Here's going to be our critical value, Z0, right? Or T, this is actually T0, sorry about that. I don't know if I put T0 over here. I didn't, but this is T0 because we're using the inverse T, right? So again, my area to the left, y'all, is 0.10. That's the area over here. So again, when I go with inverse t, I'm going to say the area to the left is 0.10. Remember, my degrees freedom is 1 less than my n. So look, let's do the same thing we did before. Second vars, inverse t, 0.10, comma 34. And look what the number we're coming up with, negative 1.31, right? So right here, my T0 is a negative 1.31, right? So again, this is my, this is my rejection region. And this one here is my fail to reject, okay? So when we find our standardized test statistic, we want to know where are we going to fall. If we fall to the left of negative 1.31, we reject. And if we fall to the right, then we fail to reject, okay? One last case scenario. Alpha is still 0.10. My S is still 4.8. My N is still 35. Oops, that sounded very pretty, 35. Let's fix that. Okay. And so now what we're going to say, our ha is going to say that mu is not equal to 38. This is telling me that we now have a two-tailed test, right? So I'm going to come back over here. I'm going to draw my picture just like we did before, okay? Since we're looking at a two-tailed test, we're going to have two critical values, right? One's going to be negative, one's going to be positive, right? Remember what we're going to do, y'all? We're going to take our alpha, we're going to divide it by 2. So the area to the left over here is 0.5, and the area to the right over there is 0.5, okay? So again, we're going to do the same thing. We're going to go inverse t, 0.5, because it's always the area to the left. My degrees freedom is 1 less than my n. So let's come back here. Second vars, inverse t, 0.05 and 34. And I'm coming up with a negative 1.69. Okay, so this number here, negative 1.69, this one is positive 1.69, right? So again, just so that we have an idea, these are my rejection regions, and this is my fail to reject region, right? So again, if I end up with somewhere here in the middle, we're going to say we're going to fail to reject. But if we come up with a number smaller than 1.69 or bigger than positive 1.69, then we have to reject the null hypothesis. So I wanted to go through this, y'all, because it seemed like that was one of the questions, and I hope this helps, okay? If y'all got any questions, let me know.